Hello viewers, welcome to the third lecture on AC fundamentals. So far we have seen different terminologies that are used for AC fundamentals. So we have seen what is waveform, what is time period, what is frequency, what is instantaneous value, what is RMS value. Okay, then we had gone through different numericals also, wherein we wrote different equations like I is equal to Im sin omega t, V is equal to Vm sin omega t. Okay. In the second part, we dealt with purely resistive circuits, purely inductive circuits, and purely capacitive circuits. Okay, and the phase difference between V and I in case of purely resistive circuit is 0. In case of purely inductive circuit, it is pi by 2, where current is lagging voltage by pi by 2. In case of purely capacitive circuit, current is leading the voltage by 90 degrees. Okay. Now let us move further. Again, we are still talking about different vectors. Today I am talking about different operations to be dealt with the vectors. Okay. Now before that, let me start with the fact that whenever there is a vector, it can be resolved into two components. One is what is called as cos component and another is what is called as sine component. Okay, so here you can see in the very first diagram, you can see the vector f, and that has got a sine component and that has got a cos component. Okay, here the angle is specified as a, so f cos a will be equal to the cos component and f sine a will be equal to sine component. Okay, so that is how a vector can be resolved into two components. Now when I say two different phasors are to be added or two different phasors are to be subtracted, see, when I say the two different phasors are not in phase, they have a certain phase difference between them, they cannot be directly added or subtracted, isn't it? If at all they are in the same phase, they can be added, they can be subtracted. But if there is a difference in their phases, in that case the two phasors cannot be directly added or subtracted. Okay, so in such case, what we do again, as I said in the last lecture, if you remember, that any vector can be said in terms of rectangular form, or it can be said in terms of polar form. Okay, what do you mean by rectangular form is when we tell you about the rectangular part, that means you have real part and imaginary part which is said. Okay, when I say polar form, it is the magnitude of the vector and the inclination with respect to a reference phasor. Okay, now when I say phasor additions, what I actually need is you can see in this diagram that one vector is v2 sin omega t and another vector is v1 sin of omega t plus phi. That means these two vectors are having a phase difference between them, you can see over there as 60. Okay, so when I want to have a phasor sum of these two vectors, how do I do it is at the tip of this vector I draw a parallel line to this, and at the tip of this vector I draw a parallel line to this. Okay, and this is the resultant. So you can see over here there is a parallelogram formed. Okay, so normally whenever it's a vector addition or phasor addition, it is always done on a parallelogram. Okay, and the diagonal of the parallelogram shows you the resultant. Okay, yes. Now let me talk about mathematical additions when we do about any phasor. So when suppose a vector x is equal to x plus jy. Okay, so x is the real part and y is the imaginary part. Okay, so you can just visualize that on x axis it's the real part and y axis is the imaginary part. Okay, so when I say plus jy, I'm talking about plus y axis, and when it is minus jy, I'm talking about minus y axis. Okay, so when I say a is equal to x plus jy, this is a vector lying in the first quadrant. I hope you visualize it. Okay, now the second vector is b is equal to w plus jz. Again, this vector has got real and imaginary both parts as positive, so this particular vector is also lying in the first quadrant. Okay, when I want to do addition of these, what I do is it is real part added and imaginary part added. Okay, just to give you an example, if there are onions and potatoes and you are asked to sum it up, you will be giving different sum for onion and you will be given different sum for potatoes. You won't be adding potatoes and onions together, right? Okay, similar way over here, it is when I add a plus b, it is real part added, that is x plus w, plus j, it is imaginary part added, it is y plus z. Now let us say it would have been w minus jz. In that case it would have been real part x plus w, but imaginary part would have been j, in bracket it would have been y minus z. Am I clear? So what do we do in case of additions of vectors is real parts are added and imaginary parts are added. Another way to put this again is, whenever you want to do any addition or subtraction, the form you need for the vector is always a rectangular form. Okay, yes, you can see again this was addition operation. Now let us see the subtraction operation. You can see over here again the same vectors are taken. A is equal to x plus jy and b is equal to w plus jz, but now it is the operation a minus b is to be taken. Okay, in that case again we'll be doing the same thing, that real part operation and imaginary part operation. So it will be x minus w and plus j, it will be y minus z. Okay, now suppose it would have been w minus jz over here. What would have been the case? It would have been a minus b is equal to, it would have been x minus w plus j, it would have been y of minus z, so it would have been y plus z. Okay, so it would have been a minus b is equal to x minus w plus j y plus z. Okay, so that is how it is subtraction. So by now we have seen how to add two vectors and how to subtract two vectors. Okay, now next is how you do multiplication and division. Now for multiplications and divisions, the form you need is what is called as polar form. Now what is polar form? Basically when you are given magnitude and the inclination of vector with respect to a reference phasor, this is what is called as polar form. Okay, now the polar form is needed whenever you have to do operations of multiplication and division. Okay, so in case the vector given to you is in the rectangular form, you will have to convert it into polar form by your calculator, and then you have to perform the multiplication or division. Okay, so let us say some vector z1 is given as r1 at an angle theta 1, and let us say z2 is given as r2 at an angle theta 2. Then z1 into z2, that is the product of these two, will be it will be simply normal product of the magnitudes, so that is r1 into r2, and angle will be theta 1 plus theta 2. What I mean over here is that the phases get added up. Okay, so again let me repeat, when it's a product of these two, it will be z1 into z2, that is equal to, it will be simply product of the magnitudes, so it is r1 into r2, and angle will be the sum of these two phases when it is multiplication. Okay, similarly if at all it is a division like z1 upon z2, in that case it will be simply division of the magnitudes, that is r1 upon r2, and angle will be numerator's phase minus denominator's phase. I repeat, when it is z1 upon z2, that is a division is to be done. In that case the magnitudes are simply divided, like numerator magnitude divided by the denominator magnitude, and angle will be numerator's phase minus denominator's phase. Okay, so you have to just simply remember that whenever it is addition and subtraction, you have to have phasor or vectors in terms of rectangular form. Okay, and whenever it is multiplication and division to be performed, it has to be always a polar form. Okay, yes, let me just give you a few examples which are solved over here. The very first is a 50 cycles per second, 1 cycle per second is 1 hertz, so 50 hertz alternating voltage of 230 volts supplies a current of 2.3 amperes to a purely inductive coil. Now here it is purely inductive coil, that means Z is equal to XL. Okay, so there is no resistance. Okay, you have to find inductive reactance, you have to find inductance of the coil, you have to find power absorbed, equations of voltage and current, and you have to draw the phasor diagram also. Okay, so here XL will be equal to V by I because it is purely inductive circuit. I hope you remember the last lecture, okay, wherein we have dealt with a chart in that one of the branch of the chart was purely resistive circuit, another was purely inductive circuit, and the last one was purely capacitive circuit. Okay, so we are talking about the middle branch. This is purely inductive circuit. In this case the resistance offered to the current will be only inductive reactance. Okay, what is this inductive reactance? Now over here is V upon I, so that will be 230 upon 2.3, that is 100 ohm. Okay, now you have to find out the value of inductance also. So to find out inductance, you'll have to put it up as XL is equal to 2 pi FL, okay, and it will be then L's value as 0.318 Henry. Okay, of course you have to pay attention to the units also. XL is in ohms and L is in Henry. Okay, yes. Next is power is to be found out. So power absorbed is equal to, you can either find it out as I square R, or you can find it out as VI cos phi. But since it is purely inductive circuit, if it is purely inductive circuit and purely capacitive circuit, the power consumed is 0, because phi is equal to pi by 2 and cos phi by 2 will be equal to, yes, 0. Okay, so anything multiplied by 0 is going to give you 0. Next is voltage equations. So V is equal to Vm sin omega t. You have been given, see, it is always the case that whatever are the values given to you are always RMS values. So here the value of the voltage is given as 230. So this is RMS value, but while writing the equation I need maximum value. So maximum value will be root 2 times the RMS value. Okay, so V is written as root 2 times 230 into sine of, it is omega t. What is omega? Basically it is 2 pi f, and what is frequency in India is 50 Hertz, and the same is given in your problem also. Okay, so it is sine of 3140. So it will be 325.26 sine of 3140. Okay, what about current? Now it is purely inductive circuit, that means the current has to lag by 90 degrees exactly. Okay, so what will it be? It will be whatever currents value you have got. Okay, so it is 2.3 amperes, right? So 2.3 amperes is an RMS value, is to be multiplied by root 2 to get the maximum value. Then sine of it will be 3140 minus pi by 2. Why minus pi by 2? Minus to depict that it is lagging behind the voltage, and pi by 2 is the phase difference between V and I. Okay, so what is the current equation? It is 3.252 sine of 3140 minus pi by 2. I hope it is clear to you. Okay, now the second question. The second question is, a sinusoidal 50 cycles per second current of maximum value 100 amperes flows through a capacitor of 318 microfarad. Find expression for instantaneous current, reactance, equation of instantaneous value of applied EMF, RMS value of EMF and current. Now mind well, over here it is pure capacitor given to you because there is no resistance mentioned. Okay, so XC will be equal to V by I. Is it clear to you? Okay, now again one more thing is, here the value of the current is given in the maximum value terms. So RMS value will be maximum value upon root 2. Okay, so very first thing is you have to find out XC, because capacitance value is given in the microfarad terms. Okay, so XC is equal to 1 upon 2 pi FC. If you substitute it, C as 318 microfarad, that is 318 into 10 to the power minus 6 into 2 into pi, to be taken directly from the calculator, into 50, that is frequency, and take the reciprocal of this or inverse of this, you will be getting 10 ohm. Okay, second one is the maximum value of voltage, that will be Im into XC. Okay, so maximum value of current is given to you as 10, multiplied by 100 will give you the value of the maximum voltage. Okay, then it is equations of voltage and current, EMF and current, to be more precise. So V is equal to Vm sin omega t. Maximum value is already found out. Sine of it will be 3140. Now just because we are talking about purely capacitive circuit, I will be equal to 100 sine of 3140 plus pi by 2. Why plus pi by 2? Because in this case the current should be leading. Deliberately I wrote over here minus pi by 2 to check whether you are all sleeping or understanding the things alert. Okay, yes, so IRMS is equal to Im by root 2, so that will be equal to 70.7, and VRMS will be equal to Vm by root 2. Okay, so Vm is 1000 by root 2. Okay, you have to find out these values. Okay, so that was about AC fundamentals third lecture. I will again meet in the fourth lecture. Okay, see you then. Take care. Thank you.